we're asked, do the points on the graph below represent a function? So in order for the points to represent a function, for every input into our function, we can only get one value. So if we look here, they've graphed the point, looks like -1, 3. So that's the point, -1, 3. So if we assume that this is our x-axis and that is our f of x axis, and I'm just assuming it's a function, I don't know what it really is just now, this point is telling us that if you put -1 into our function, or that thing that might be a function, or maybe our relation, you'll get a 3. So it's telling us that f of -1 is equal to 3. So far, it could be a reasonable function. You give me -1, and I will map it to 3. Then they have, if x is 2, then our value is -2. This is the point 2, -2. So that still seems consistent with being a function. If you pass me 2, I will map you, or I will point you to -2. Seems fair enough. Let's see this next value here. This is the point 3, 2 right there. So once again, that says that, look, if you give me 3 into my function, into my black box, I will output a 2. Pretty reasonable. No reason why these points can't represent a function so far. Now, what about when we input 4 into the function? Let me do this in a new special. Let me do this in magenta. So what happens if I input 4 into my function? So this is 4 right here. Well, according to these points, there's 2 points that relate to 4, that 4 can be mapped to. I could map it to the point 4, that's 5 up here, 4, 5. So that says if you give me a 4, I'll give you a 5. But it also says if you give me a 4, I could also give you a -1, because that's the point 4, -1. So this is not a function. It cannot be a function if for some input into the function, you could give me 2 different values. And you can see that right here. And an easy test is to just see, look, for one value, I have 2 points for this relation. So this cannot be a function. So this is not a function. I'll put an exclamation mark.